the game changer, the God equation. What is it? The Schrodinger's equation. Right. So listen to me very carefully. Now, yeah, it's like playing chess. Sometimes you make a random move, right? And then sometimes you see the big picture later, right? It's like playing chess sometimes. So all you have to do is now, not you actually, but Schrödinger did was, he was finding for something that describes the momentum operator, right? So what he did was, all of a sudden he decided to get and see uh, the first derivative of x. This is called the spatial derivative. So what he did was he got the spatial derivative of this wave function. So even let me do the same, right? I have no clue yet, but let me work it out and see what we will end up with, right? So now I'm going to put the spatial derivative, very first one. So double x, sorry, phi xt and double x. Let me see what I end up with, and even here normalizing constant, and here I kx minus omega t, and here again double x, right? So now I can clearly see that for simplicity I'm going to write it like this hereafter. Let me keep it as it is, right? And then here a is a constant anyway, and here omega t turns out a constant, as here it is yeah, it is a t, here we consider double x, so that t would be treated as a constant here, so that we'll end up with I here and here k, and now exponential again I kx minus omega t, right? Now you can clearly see that this one and this one, when you combine these two parts together, that is exactly the wave function again, right? It's the wave function itself. So I can finally end up with x is equal to the wave function, or you can say I k wave function. Yeah, so you might sometimes you might disagree with me. This is not a ik, doesn't make any sense. It's not actually momentum. So what is the use of this? You might be wondering. Let me hold on for a while. I'm going to show you. Now, though we ended up with something like